Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude, and this is lecture on area and perimeter of basic geometric figures. So till now we have discussed about lot of geometric figures like triangle. We studied various types of triangle, and later we moved to rectangle, square, and rhombus, parallelogram, trapezium, and we also solved a couple of problems based on them. So today we are going to move ahead with polygons. So what is a polygon? A polygon is a closed plane figure formed by three or more line segments. So one important thing is here to notice it's a closed figure and it is formed by three or more line segments. Okay, and each side intersects exactly two other sides and one at each of its endpoints. No two sides with a common endpoint overlap except at the midpoint. So that is a polygon. Sum of interior and exterior angle of a polygon. The interior angle of a polygon add up to n minus 2 times of 180 degree, where n is the number of sides. So suppose if I have a polygon with like something like this. Suppose this is a polygon with five sides, 1, 2, 3, 4, 5. So n will be 5 here. And if I put n equal to 5 minus 2 into 180, so this will be 3 times of 180. So that means the interior angle of polygon for this one will be 3 times 180. And the sum of interior and exterior angle of any vertex of the polygon is always 180 degree. We have two types of polygon, that is irregular polygon and regular polygon. A polygon is regular if all of its sides are of equal length and all its angle are equal measures. If the sides or angles are of unequal length, then the polygon is said to be irregular. So for a polygon to be regular, all of its side should be of equal length and all of its angle should be of equal measure. If this condition is not satisfied, then we say the polygon is irregular. A diagonal is a line segment that joins two non-consecutive vertices of a polygon. So suppose if I take this polygon and this is one vertex, this is another, and this is the third one. So this one and this one is consecutive vertices. We want non-consecutive. So if I join it like this or towards this one, so these line segments are called a diagonal. And number of diagonal in a polygon with n sides is given by n into n minus 3 by 2. So if you know how many sides are there, or if you know number of sides, then you can easily substitute the value of n in this formula and you will know how many diagonals can be made in that particular polygon. So let us have a look over the problem. The problem number 1. Each interior angle of a regular polygon is 108 degree. Find number of sides of a polygon. So in this question, in interior angle of regular polygon is given to us and we are interested in finding number of sides of the polygon. So which formula are we going to use? If you remember, we had a formula in which we studied about interior angles of a polygon. This one, n minus 2 times of 180 degree. So the sum of all interior angle of a regular polygon is going to be n minus 2 into 180 degree. That is known to us, correct? And we are interested in finding the value of n, correct? Now, it is given that each interior angle is 108 degree, and since it is a regular polygon, if this polygon was not regular, we will not be able to do what I am just about to do. Since each of its angle is equal and sum is n minus 2 into 180, and there are n sides, so I can divide it by n to know the interior angle of one. Okay, so each interior angle of the regular polygon can be obtained by dividing this sum by n, because it's a regular polygon. Each and every angle is of same measure, each side is of same length, so I can divide it by n, correct? So now I know interior angle of each. Okay, and it is given to us to be equal to 108. So what you have to do is just simply equate this thing to 108, and on simplification, I will have 108 degree times n equal to 180 degree times n minus 360 degree, and at last it will be n equal to 5. So the correct answer should be n equal to 5. So this polygon have 5 sides. Problem number 2. The ratio of exterior angle to interior angle of a regular polygon is 1 is to 4. So the ratio of exterior angle and interior angle is given to us, that is 1 is to 4. Then we have to find the number of sides of the polygon. Let the exterior angle of polygon be x. Then the interior angle of polygon is going to be 180 minus x. So how did I do that? How I know that? It is already discussed in the previous slide that sum of interior and exterior angle at any vertex of a polygon is 180 degrees. That's what exactly we are doing here. We assume exterior angle to be x and interior angle will be nothing but 180 minus x. So according to the question, a ratio is given to us that exterior angle is to interior angle is 1 is to 4. So x upon 180 degree minus x is 1 upon 4. So on simplifying this equation, it will be 4x equal to 180 degree minus x, 5x equal to 180 degree, x equal to 36 degree. Therefore, number of sides of polygon is equal to 360 degree upon exterior angle, that is 360 degree upon 36 equal to 10. So in this question, the answer is going to be 10. So this polygon will have 10 sides. So let us now move ahead to circles. So a circle is a very interesting thing. So this round figure that you are able to see at your screens is called a circle. And in this circle, there is a center point. This is a center point, and this line, orange line, represents the radius, and it is constant throughout the circle. From, from this point to any point on the circle, this length is always a radius. And this is what we call a diameter. And if I am standing at this point, if I am standing at this point and keep on walking like this on this circle, that is circumference. It is total length of this line. In simple words, if I have to say, it is total distance that I cover while starting from this point and moving along complete circle and coming back to this. It is nothing but a circumference. So the diameter d, the distance across the circle passing through the center. So d is 2r, where r represents the radius of the circle. So this d is equal to 2r. This can also be clearly seen from the figure, because from the center point to this point, this length is radius. From the center point to this point, this length is again radius. So if I have to ask what is the length, this complete blue line, so it is, this one is radius and this one is also radius. So radius plus radius. So that is 2 radius. So that's exactly what is written here. Diameter equal to 2 times of radius, and here it is denoted by r. So d equal to 2r. Area and circumference of a circle. The area of circle is calculated by multiplying pi by the square of its radius. So area of a circle is given by pi r square, where pi is sometimes used, pi is by the way an irrational number, and sometimes for obtaining answers quickly, it is approximated to 22 by 7, or we often use 3.14. This is the approximation. Exact value of pi is not known till date, and it will never be known because it's an irrational number. This thing we have already seen in previous lectures for number system, where we discussed why pi is an irrational number. And circumference, or I can say perimeter, is 2 pi r. Okay, so again pi is approximately written as 22 by 7 or 3.14. What is the arc length of a circle? So arc length of a circle is denoted by S. And if I talk graphically or geometrically, so if this is your pizza and you take a slice, in that slice, this length, this is your pizza slice, complete pizza slice. Okay, this is your complete pizza slice, and this length in this pizza slice is your arc length. And this arc length is given by 2 pi r into theta by 360 degree. Okay. Area of sector. Area of sector is nothing but, again, suppose you have a pizza, you have a pizza, correct? And you divide it in, and whenever you order a pizza from a restaurant, it's already divided into sectors, and this is what we call the sector. So we are interested in finding the area of that particular sector. So it is actually the portion of pizza you ate in one slice. That's a slice of a pizza, and we are interested in finding the area of that slice. So it will make some angle theta, and this is radius r, this is radius r, this length. So area in terms of degrees of this sector will be given by theta upon 360 into pi r square. And in terms of radians, the area will be given by theta by 2 into r square, where theta is the central angle and r is the radius of the circle. What is a semicircle? So we have a circle, and if we cut it half from the center line, then this remaining portion is what we call a semicircle. So the formula to find out the area of semicircle is nothing but half of the original circle. Because how semicircle was obtained? The semicircle was obtained by cutting the circle into two equal portions. So if this is your circle, I cut it into two halves. So this area and this area is same. So the area of complete circle is pi r square. Then what is the area of semicircle? Definitely half of the original area of the circle. So that is what is written here. The area of a semicircle is pi r square by 2, where r represents the radius of that circle and pi is 3.141, and that's what we have. What is the circumference of a semicircle? So earlier we had 2 pi r, correct? Earlier we had 2 pi r. Okay, so this doesn't actually look like a circle. So earlier we had 2 pi r, correct? So that's the distance. I started from this point and kept moving and reached back. So this is the circumference. But what about the semicircle? Because it is partitioned into two halves. And now the semicircle have this this part and this part. So I have to find the I have to find the circumference. So this part is pi r, because if I talk about the perimeter or circumference of the complete circle, it was 2 pi r. So we have half the thing. So the remaining this portion is nothing but pi r, correct? But this time we have this portion extra, this base, or I should say diameter, and this length is r, and this is also r. So this complete length is going to be 2r. That's exactly what is written here. Circumference is nothing but pi r plus 2r. So that was all about circle and polygon. Let us now see couple of questions based on the theory that we have discussed recently. So length of each side of a square is twice the radius of a circle. If the radius of circle is 7 centimeter, then what is the difference between the area of square and the circle? So it is given that length of each side of square is twice the radius of a circle. So there is a circle whose radius is suppose r. Then the side of square is going to be 2r, correct? A relation between side of a square and radius of a circle is given to us. Now we are interested in finding what is the difference between the area of circle and area of square. So that is what we are interested in. Let us quickly recall the formulas. The area of circle is given by pi r square, where r is the radius of the circle. Area of square is given by side square. Measure of each side of square is 7 times 2, because radius of circle is given to us equal to 7 centimeter. So the measure of each side of square is will be 14 centimeter. So area of square will be 142. How we compute it? We just simply put the value of the side, length of side, that is 14 centimeter, in the formula of area, area of square. So that is 196 centimeter square. Okay. And now area of circle is given by pi r square. So r is 7 here. So it will be pi into 49, that is 154 centimeter square. So we are interested in finding the difference of the squares, area of square and the area of circle. So that will be 196 minus 154, that is 42 centimeter square. So correct option is option number C, that is 42 centimeter square. Let us move ahead to question number 2. The radius of circle is 3.5 centimeter. Find its circumference of the circle. So the radius of a circle is given to us and it is asked to find the circumference of the circle. So the given radius of r is 3.5 centimeter, and we know that the circumference of a circle with radius r is 2 pi r. The circumference of a circle is equal to 2 pi r, equal to 2 times of 22 by 7 into 7 by 2, equal to 22 centimeter. So that was a very easy question, and the final answer is option number B, that is 22 centimeter. Let us move to question number 3. The circumference of two circles is 132 meters and 176 meters. So here we have two questions, and their circumference is known to us. So what is the difference between area of the larger circle and the smaller circle? So our goal is to find the difference between the area of larger circle to the area of smaller circle. So to find the area, first of all, look at the formula to find the area. Area of circle is equal to pi r square. So that means we need the value of r here, which is unknown to us. But information is given to us which can help us to find the value of r, that is circumference of these circles. So the circumference of the circle is 2 pi r. Using this formula, we can find the value of r. So 2 pi r1 equal to 132. So r1 will be 132 times 7 upon 2 times 22. So that is r1 equal to 21 meters. The same thing we are going to do for R R2. 2 pi R2 is equal to 176, and R2 equal to 176 into 7 upon 2 times 22 equal to R2 equal to 28 meters. So the value of first circle is 21, and the length of the radius of second circle is 28 meters. So we want to find the difference between the larger circle area of larger circle and the smaller circle. So it will be given by pi r2 square minus pi r1 square, and it can also be written as pi r2 square minus r1 square. So just substitute the values of r2 and r1 here. You will have 22 upon 7 into 49 into 7 equal to 1078 meter square. So 1078 meter square is your correct answer. That is option number C. So let us move ahead to question number 4. So in question number 4, the sum of radii of two circles is 140 meter centimeter, 140 centimeter, and the difference of their circumference is 88 centimeter. Find the radius of two circles. So relation between sum of these two circles, sum of radius of these two circles, and the difference of their circumference is given to us. We are interested in finding the radius of these two circles. Let us suppose the radii of two circles is R1 and R2. So their sum is given to us to be 140. So that is R1 plus R2 will be equal to 140. So R1 is equal to 140 minus R2. And let us name this equation to be equation number 1. And it is also given that the difference of the circumference is equal to 88. So 2 pi r1 minus 2 pi r2 is equal to 88. On simplification, I can take 2 pi common and send it to 88. So it will be r1 minus r2 equal to 88 upon 2 pi. Putting the value of r1 from equation 1, we have 40 minus r2 equal to 88 times 7 upon 2 times 22. So 2 times R2 equal to 140 minus 14. So R2 will be 63, and putting the value of R2 in equation 1 to obtain R1, and it will be 140 minus 63. So R1 will be nothing but 77. Therefore, the radii of two circles is 77 centimeter and 63 centimeter. So the correct option should be 77 centimeter and 63 centimeter. That is option number A. Let us now move ahead to question number 5. In question number 5, the perimeter of a semicircle is 36 centimeter. Find the area of semicircle. So the perimeter of a semicircle is known to us, and we are interested in finding the area of the semicircle. So the perimeter of semicircle equal to 2 pi r plus 2r, correct? And area of semicircle is given by pi r square upon 2. So now perimeter, what is the perimeter of semicircle? It is 36, that is given to us. So directly substitute the value here. So pi r plus 2r equal to 36. Take r common, correct? And now you will have r times of 22 by 7 plus 2 equal to 36. R times of 22 plus 14 by 7 equal to 36. On simplification, you will have 36 upon 7 times r equal to 36. 36 will get cancelled, and r is 7 centimeter. So what was our main goal? our main goal was to find the area of semicircle. And area of semicircle, as we discussed, is given by pi r square upon 2. Now substitute the value of r here. Area of semicircle equal to 1 upon 2 into 22 by 7 into 7 into 7. 7, 7 get cancelled. We will have 11 by 7 into 7 into 7. It will be 77 centimeter square. Therefore, the area of semicircle is 77 centimeter square. So option number C is correct here. So that was all for this lecture. And in this lecture, we studied about polygons, we studied about circles, and we also discussed a couple of problems based on the polygon and circle. Thank you very much.